time the tamping is done, the new alignment is created without any reference to the previous alignment. So every time the new references are created. When we have to do the tamping again, in the design mode, again we have to pick up the versins, do the calculations and feed the slews into the tamping machine, PLC of the tamping machine, and in this method the design versins are changed. Every time we do calculation, we change the design versins. In fact, geometry of the curve is changed. In this method, the alignment and profile defects or level defects, they are reduced in the extent. They don't go away even after the several rounds of tamping. For correcting the dips also, sometimes if the L section is not made, then the correction of dips have no regard to the L section. Supposing we have not drawn the L section, then those correction of dips will be irrespective of the L section or the index section. Now we will see what are the requirement of survey for the pre and post tamping. We require center line coordinates at every 5 to 10 meter accurately in terms of northing, easting at all. We require coordinates and restrictions of the obligatory points. So like bridges are there, like turnouts, level crossings, and there are OHE mast, signal post, boxes, signal boxes. They are all may create restrictions in the slew or the determining the alignment. So these they have to be picked up. Then also the special features like gradient, start of curve, end of curve. Where the vertical curves are there, they also have to be picked up. Then super elevation, degree of curve, everything have to be picked up during the survey. Then we determine the design alignment. If we have the designed alignment, then we use the designer, otherwise we will have to design the alignment based on the center line coordinates. Then if we have designed alignment, then comparison with existing alignment to design alignment will give us the slews, lifts and tilts. Tilts are the super elevations. So basically we require slews, lifts and tilts for the tamping machine to rectify the track. Now we will see the global coordinate system. What are the? You have already been exposed to it. It may be repetition, but this is a specific reference to the survey for the pre-tamping and post-tamping work. Global coordinates have longitudes, latitude and altitude like this. So in the geographical terms, if we want to know the location of any points, say on the globe, we require longitude and the latitude. These are the vertical lines and longitudes, and these are the latitudes. And in this hemisphere, we have northing, and this direction will be easting. Likewise, this direction will be west, and north, NW, northing and westing, and here it will be southing and westing, here it will be southing easting. So these are the coordinates based on the longitude, latitude and the altitude. Then we have WGS 84, that is World Geodetic System, which survey was done in 1984, and thereafter it has been updated number of times, and based on this survey or another coordinate system of UTM, that is Universe Traverse Marketer system of coordinate has been developed. You can see here this entire globe is divided into number of sectors, and these vertical lines are at 6 degrees. Every 6 degrees these sectors are there, and in the latitude direction also it is 6 degrees. So every 6 degree side here it is 42. India is starting from 42, 43, 44, and some part will be in 45 also. And here it is, alphabet is P, Q, R, and some part will be in S. So this will be sectors for the UTM coordinate system. So this is the UTM. Then if we have to convert the UTM coordinate or longitude latitude coordinate, then there are a number of tools available, and one tool is awesometools.com. From this site we can convert the latitude longitude into the UTM coordinates. Say, let us see. Are you able to see? No.
Global coordinate system is there.
नहीं, ये वेबसाइट नहीं खुला.
वेबसाइट नहीं खुला.
अच्छा, दिख नहीं रहा. ये दूसरी स्क्रीन में खुल रहा है. Anyway, these tools can be used to convert the one system to another, and there are other tools are also available. As we have discussed, it has got northing, eastern and altitude. The reference system, as we have discussed, it is a GTS mark system, benchmark system is there. In the initial we have discussed like these type of GTS, and these are the control points. Control points are also kept, and like this they have marked in the Bangalore development authorities, and this will have northing in the easting and altitude value. Now we have in place of GTS benchmark, we have GCPs, ground control points. Again, these have standard values based on the survey. Control point means northing, eastern and altitude. All three values are available at these points. Then for getting the control point references, DGPS is used. Like this is the device, DGPS device, and it is its controller. By observing the satellite constellations for 48 hours, the base station references are established. We will discuss further also. Then we have primary control points. Primary control points. So these are the basically reference points. Primary control points are at every 10 to 20 kilometers. They are established by DGPS, differential geopositioning system. And secondary control points are at 1 to 2 kilometer, and tertiary at every 150 to 200 meter. So these are this is one, you can see the circle there, there is a primary control point. Then we have secondary control points along the alignment at every 1 to 2 kilometer, and then these are the tertiary control points or tertiary reference points at every 150 to 200 meters. These are required to be established by triangulation survey after we get the position of primary reference by DGPS. As we have discussed secondary and tertiary control points, now the system of conducting pre-tamping survey. How we have as we have discussed, the earlier alignments are done with the Theodolites, level instrument, and the coordinate sighting method. Like we can see here, they are doing with the Theodolite, and they are measuring the distance of track where the Theodolite is positioned. So since it is difficult to set up the Theodolite on the central line of the track because of the tail movement, then we have to do this by side by taking a parallel alignment. By this Theodolite we carry out the survey in the present method. Then we have total station and the prism. Now this is, in this method, the prism is placed at the center line of the track, and its position, its coordinates are picked up by total station, and this way at every 5 meter the coordinates of the center line are picked up, and then alignment is designed, redesigned or worked out again. Then we have single trolley systems. In this single trolley system, the total station is placed outside the track where the prism trolley is moved on the track. And it has got computer, handheld computer, which gives it online, which picks up the coordinates as well as compares them with the design alignment. Then we have double trolley system or twin trolley system. Like this, one trolley will be total station trolley, other trolley will be prism trolley. Like this, you can see the prism, and here it is total station. This is also another view, closer view of total station. It is a robotic total station. It can align itself towards the prism. And there is a tri-batch also, a specially designed tri-batch. This is there to many companies which are making this system. Trimble system. Trimble is basically survey equipment manufacturer. Amber Trolley is another this type of. Principle is the same. Prism trolley as well as total station trolley. Then what is required is, this is say blue line is existing alignment or as built or as maintained alignment, say blue line, and the red line is the designed alignment. So this design alignment, we pick up the coordinates, center line coordinates of the existing alignment, then design the profile, and then work out the slews at every 5 meters. The control point, number of control points are required to cross check that the coordinates are accurately picked up by the method. Inclination sensor, which gives the super elevation or the cant. There is a controller also. Controller means it's a sort of a computer which is mounted on the prism trolley. There it will be picking up the data, and after comparing with the design values, it can also give the display the slews and lifts while moving at the walking speed. Then it has got radio communication system, where which controller can communicate with the total station trolley as well as the prism. The system is hardware and software. In this system is designed in such a way that they can do the railway work very smoothly. So both the hardware and systems are designed for doing the railway work. Pre-tamping and post-tamping survey of alignment. So what are the process? We have to start with setting up the base station. Like base station, we have seen this. This is DGPS measurements are to be done for setting up the base station. And this is the controller of the DGPS. What are the methods? UTM first we have to know the UTM, our location as per the UTM zone, appropriate zone. Say 42 zone, 43 or 42 depending upon the geographical location. That zone we have to know. Then the base station is set up by DGPS R6 receiver, and it observes the signal from the satellites for 48 hours continuously for error correction. So 48 hours required because there is some variation which is in the satellite constellation. If we observe for 48 hours, we get the accurate value of the position of the base station. Then signals are observed from the 16 satellites. 4 or 5 also can be done, but more signals means more satellite signal means more accurate. Exact location of the base station is marked with paint and nail. So whenever we have to mark, we have to insert the nail and mark with the paint and exact location. At the exact location on the concrete base, so it is permanent type of thing. Then so the signals, the references we get at the DGPS level. So we need to know the height of the reference point to the reference point on the ground to the DGPS. So that height is to be kept fixed from the ground level, from where we are establishing the control station, base station. And we get coordinates and also the altitude of the reference point at the base station. And this is the schematic of how the base station is established. Say this is the base station. This is the base station, and this is observing five constellation of 5 satellites, and this is conveyed to the rover. Basically, in this method, we get the reference point. Say we establish this point on the concrete pillar, and if we know this distance, we can calculate this reference point. So in this method we will get this point. So we will have to transfer to the reference point. So this way we will establish the base point, base station. Then we have to establish primary, secondary and tertiary control point as we have discussed. Primary at every 10 to 20 kilometer, secondary at 1 to 2 kilometer and tertiary at every 150 to 200 meter, so that references are laid out very accurately. Then we know what standard we have to achieve. What are the accuracy requirements for the track to be achieved. Then we do the pre-tamping survey. We will discuss in detail what are the pre-tamping survey. In the pre-tamping survey, we need coordinates at 5 meter interval. Then we know we need coordinates of the obligatory points and special features for redesigning the alignment. The alignment, after picking up the center line coordinates, the alignment is designed using the software. Standard software like Bentley is there, Bentley Open Rail or the Civil 3D, and they are transferred to AutoCAD. From that we will get the center line design coordinates of the center line of track. Then alignment and level crossings, level corrections are fed into the tamping machine, ALC of the tamping machine, and with progressive round of tamping, the existing profile is corrected to the brought nearly as accurately as possible to the designed alignment, which has been designed in step 7. Then as built alignment is also picked up after we have completed the tamping. Then as built alignment pick up and compared with the design, and it is used for future reference. This is also used for फ्यूचर में अगर हमें जरूरत है तो उसकी हमारे पास परमानेंट डेटा अवेलेबल रहता है. Now we will see how it is done. So this is the instrument trolley. Instrument trolley we have seen. Say we have to start from this control points. We have to place opposite the control point, tertiary control point. These are at 150 to 200 meter interval. They can be on the alternate OHE mast, or pillars we have to erect at every 200 meter, and they have the known coordinate points. So the instrument trolley is first placed opposite the control point, on the track opposite the control point, and the prism is kept. This is not prism trolley. Separate prism is kept at control point. So, and the instrument trolley sides the instrument robotic total station sides the prism at the reference point or the control point, and based on the value of coordinates of the first control point, the value of coordinates of the position, the value of coordinates of the instrument or the total station is captured. After this, the instrument trolley is moved to the second control point. ये सेकंड कंट्रोल पॉइंट पे ट्रॉली चलाते हुए चले आए और सेकंड कंट्रोल पॉइंट के सामने पोजीशन कर दिया और फिक्स कर दिया. इट इज फिक्स अपोजिट टू द कंट्रोल पॉइंट. नाउ अगेन the total station is sighting the prism at the second control points, and this is the known reference point. On the basis of this, the coordinate where instrument trolley is placed are established. तो इसके coordinate यहाँ establish हो गए. Now this instrument total station, here it is locked, fixed at this second control point, and then the prism trolley is placed opposite the first control point. ये first control point के opposite prism trolley place कर दिया. Now this will sight and establish. Total station will sight the prism at the prism trolley. So this will establish the long chord between the first control point and the second control point. Okay, I think it should be clear. Then this prism trolley will be moved towards the instrument trolley, and while moving it will pick up the coordinates at every 5 meter interval. हर एक 5 मीटर इंटरवल पे कोऑर्डिनेट्स पिकअप करते चले जाते हैं ये every 5 मीटर. और जब यहाँ वहां पे पहुंच गए उसके बाद this trolley is moved to the third control point, and then again this place at second control point, and this process is continued. So this is how central line coordinates are picked up at every 5 meter interval. If there is obligatory points, that also is picked up. Obligatory point pick up करने के लिए normal prism यूज करना होगा, जो पहले यूज करा, पहले स्टेप में यूज किया, उसके लिए प्रिज्म यूज करना होगा ऑब्लिगेटरी पॉइंट को पिकअप लोकेशन पिकअप करने के लिए. Again this will be moved like this. This is how the prism trolley is moving toward the second control point. So this was the procedure. We will not go into, and by this method pre-tamping survey is completed. Now if we have the designed also available, designed alignment is available, then the controller placed on the prism trolley displays the difference between the designed alignment and the existing alignment, which will be useful in the second round of tamping or third round of tamping. Every time we have to pick up the center line coordinates. In case of existing, first we have to make the design profile based on the central line coordinates of existing. Then once we have design profile, then subsequently it will be compared to whatever the central line coordinates are, they will be compared with the design profile. And the GDO software, which has got the trolley system, has got This generates the designed alignment as per the requirement of the railway administration. Output is further processed into the ALC format and transferred to the tamping machine. तो इसका जो फॉर्मेट सेम फॉर्मेट सॉफ्ट कॉपी ही टैंपिंग मशीन में चली जाती है. सॉफ्ट कॉपी से डाउनलोड करके टैंपिंग मशीन से एएलसी में चलेगी, उसके बाद टैंपिंग कर लो. तो आउटपुट कैसा दिखता है? द आउटपुट इज से एट दिस चेनेज द स्लू इज गिवन, अपलिफ्ट इज गिवन एंड कैंट. Gauge is also coming, which cannot be corrected, but at least it will give the idea where the effort for gauge corrections are required. Say here it gives the slew value and the lift values. Like this, it gives the cant also. So these basically corrections required to be done in the cross levels. So one thing is there, how the tamping machine will know that this is the point. So if we have say started at say some point, this is the control point. So for starting we need to synchronize the tamping machine with the any known point. Better if it is done at the control point, opposite the control point, or it can be any point with the known chainage. That chainage has to be recorded in the tamping machine. Just to make the reference of the tamping machine same as that of the survey reference. So tamping machine can start the tamping say in this direction, and the synchronization is done at the starting. After one round of tamping, that pre-tamping survey has to be done again. So whatever the residual lift and slews are there, they can be picked up. As you know, there is a limitation of tamping of maximum 50 millimeter lift slews and 40 millimeter lift. So keeping these in mind, stages. So at first stage what is to be tamping, what is to be achieved, then at second and third. Like that way we have to program so that tamping is done accurately in stages, and after every round of tamping we have to do this exercise again. Pre-tamping data have to be picked up again. Then now design is not to be worked out. Now it has to be compared, and whatever residual is there, that has to be done in another 1 or 2 rounds of tamping. Say like this is the alignment which has been achieved on South Central Railway, and say if you can, this is the designed one. Blue color is the design profile, designed alignment, and existing is shown with the green, and red is after one round of tamping. After one round of tamping, this red line is achieved, and say after the residual we have to continue so many round of tamping so that we achieve the designed or the targeted alignment. It may require 2 to 3 rounds of tamping depending upon the amount of slews which are to be, slews and lifts which are to be done by the tamping machine. After completing the design, reaching to the design alignment, we have to final build as built profile is recorded and preserved for the future maintenance reference. These both type of timber and basically survey trolleys है, इसमें basically total station और prism है और software है. They can also be used for slab track and clearance survey of tunnels. Tunnels where there is a movement of inner side, very small, but it is there. So every time and again we have to do the clearance survey for any infringement to schedule of dimensions. That also can be done by survey trolleys. So in South Central Railway they have done, and this is the for 30 kilometer. This is the timeline. Setting of base station के लिए 2 days. 2 days required. And then for reference point on every alternate mast. This is the tertiary, secondary and tertiary control point. For that 7 days are required for 30 kilometer. So this is very big work. And these reference points will be available for all the time to come. So whenever we have to do again, then also we can get this. And then recording of track center line coordinates at every 5 meter interval. It requires 8 days. Then processing of data for design profile, and then giving result is 3 days. Then tamping with ALC and post measurement. इसके लिए 15 days. Tamping में basically block requirement we get only about 1 to 2 hours block. So that require lot of time. 15 days were taken for one round of tamping. Then processing of data for the final result is 3 days. So total 38 days are required to do alignment and profile correction with survey trolleys as well as the tamping machine. What are the reports we can get? We will get the report of reference point statement, pre-tamping measurements statement, vertical alignment, track vertical alignment chart, track horizontal alignment chart, then statement of track parameters after tamping. After tamping क्या parameters है? Then statement of pre and post loose details. So and also the curve details. So these will reports you will get by this method. What are the advantages? In this method we get high accuracy, absolute and relative profile with respect to the designed profile, and we get the permanently reposition of the track alignment. Track alignment available है, control point available है, primary, secondary और tertiary तीनों ही available है. They can be used in future. Since all the steps are coordinated or synchronized, tamping time and cost is reduced. The data is delivered rapidly to the tamping machine. Utilization of tamper is improved because the data is quickly made available to the tamping machine for design mode tamping. In single operation, 3D coordinates are picked up. Any question? So far, any discussion point, any remark?
Anybody, Heman Kumar? Is it okay?
No, sir. Okay, sir.
Able to understand it, okay?
Yes, sir.
Are you able to appreciate?
Yes, sir. It's good, sir. Only time consumption, it seems time taking.
Time basically, most of the time is establishing the control points. उसके बाद जो टाइम लगता है वो टैंपिंग मशीन के टैंपिंग में टाइम लगता है. पिकअप करने में ज्यादा टाइम नहीं लगता है. 4 किलोमीटर एक दिन में कर सकते हैं.
Excuse me, sir. While Trolley is online now, when we have any cross level difference, how could it match, sir? Will it be any differences, sir?
So whatever the cross level difference is there, that will be also be picked up because we are picking up the center line coordinates with respect to the control point which are established besides the track. जैसे OHE mass पे we have made the control point that is fixed. So based on that reference point we get the center line coordinate. Is it okay?
Yes,
So,
okay, sir.
so super elevation does not play or cross load does not play any part. So whatever is available it will pick up. So this method is this method is used worldwide. सभी जगह ये coordinate system ही use होता है. When I was in Malaysia in 2006, we were using this coordinate system. Of course, that time trolleys were not using. We were using prism and the total station. So existing track coordinates used to be picked up at 10-meter interval, and we used to do the compared it with the design profile and then carry out the tamping work based on the survey with total station and the prism. Software part is also very important. There are regressive softwares available which can optimize the alignment, designed alignment and profile. So now we will discuss for more important thing. Whenever we are doing special maintenance or say large substantial amount of realignment of curve or say slewing is there, level correction is there, we are required to do de-stressing of the effective length. This is para 346 3C of Indian Railway Permanent Manual. It says that after special maintenance such as realignment, regrading, we have to do the de-stressing of the affected portion. This is very important for the major alignment and the level correction rectification. I will just explain you why it is so. Say initially we have, say this alignment we have, irregular alignment. After we achieve this. So what is this length of rail? In this irregular method was more. Now this has come, length of the rail between these 2 points has reduced. So these stresses, due to these stresses gets locked up in the rail. By doing the de-stressing, we remove this locked up stresses and so that there is chances of any buckling or any etc. is not there. when the stresses are locked up, you can appreciate that when the stresses are locked up, then they have got tendency to, alignment is tendency to go back to its original place because of the, there is a compression already. When there is a compression, there is a chance of alignment going bad again. For retention of alignment is also, this de-stressing is required for retaining the alignment, which has been corrected by tamping in this method. One more thing is important, that it is very essential that we do the de-stressing by the tensors. What will happen if we use the tensor and pull the rails? So whatever the little imperfections are there in the rail, they are also get stressed out. So by this method we get still more accurate straight alignment if we use the tensor. So whatever smaller imperfections are there, they are also getting removed. So we get the very good track, defect-free track, or the reduced, very accurate track in this method. We follow this tamping by the survey trolley method or the survey by total station method, and then do the de-stressing by tensor. We get good track. Like we will see. So we'll see tensor. By this tensor, all these stresses rails are pulled so that small imperfections are reduced or they removed, and accurate tensor is applied so that work is carried out. De-stressing is carried out as predetermined stress-free temperature. And again, one more thing I want to stress out, that we don't need to cut 1 meter rail, and we can do the welding in the same block like this. सेम ब्लॉक में वेल्डिंग करेंगे स्ट्रेच पोजीशन में ही, तो हमारी स्ट्रेसेस जो है रेल की स्ट्रेसेस मेंटेन रहेंगे, अदरवाइज दे विल गो बैक. This is what I have to say. Any question or any remark, any suggestions there, that you are welcome to make. Are you able to appreciate this?
Sir.
Yes, sir.
Sir.
Huh?
Yes, sir. Yes, sir.
Any question?
No, sir.
So thank you very much.